Just a moment.
Yeah.
Good evening, everyone. First of all, I want to thank everyone for staying. And we probably will take away something from what we're going through. Right? I know it has been 4 days. Most of us has been here, and I'm definitely staying, leaving you and your trip back home, including me. I don't know whether it's a blessing in a disguise or a disclaimer. Right? Going at the end gives you opportunity till the last minute to tweak your presentation, depending on all the content you've gone through. So I have definitely gone through most of the session in this track. So what I have noticed is, again, this could be a blessing in a disguise or a disclaimer. I will leave it to the viewer's discretion, because most of them were from an operator or a server vantage point. So this presentation, if not the only one, definitely this is one of the presentation you will see from a user or an application point of view, right? What are the tweaks we have done to get around some of the things or challenges, whatever we have seen from some of the other adjacent libraries, those kinds of things. With all of those things, let's see. Okay, here is the quick agenda, what we are planning to cover. Okay, obviously first I have to talk something about Capital One, because they are paying for me. So some details about Capital One and what really open source means to Capital One, and also what Cassandra really means to Capital One, right? We'll get into the details, what I really mean by those things. And the real meat of the presentation is couple of access patterns, what we have done in our real world usage of Cassandra cluster in Capital One rewards. First one, we will see what is that. It is something I have named it as staging. And another one we will see, which is history and current or live or history, right? That pattern. Okay. Maybe I'll just throw something, right? How many of, who doesn't really know about Capital One here? Okay. So we are one of the top credit card providers in the United States. So I was not expecting anyone to raise hand. Okay, so that's fine. So along with that, right, we are first US bank to exit out of legacy on-premise data centers and go 100% on cloud. Right? We are the only bank, and there are only 2 public companies have achieved this feat. We have made this declaration in 2015, and then we have achieved that in 2020. Right? You can imagine for any existing public company to achieve such a feat, you have to go through a lot of tech investment and also tech transformation from whatever things they have been really doing previously. That's why now Capital One is actually a tech company which happens to be in a banking business, and predominantly all our software, everything is built in-house, and there are some numbers listed here, but mostly everything is done in-house, and that is what actually we have achieved by going all in cloud. And till date, we are actually a founder-led company which stays true to its mission of change banking for good. Okay, I was going back and forth in keeping this slide. The reason is I don't want to have too much of details, but when I was talking to a couple of folks in the hallway, right, I was similar to the question I threw previously. A couple of folks asked me what I am actually doing here, or what Capital One really means, right? So even though there are a lot of other things, I actually thought I will keep this and then go through the slide and then maybe an answer to that question, right? As part of our tech transformation, we have actually started getting into the open source as part of our transformation, and what we have actually started off is at that time, since then, right, our open source adoption as well as contributions have actually accelerated. We have formed our program office in 2015, and since then we have actually contributed many projects. I have listed down few of them, right? Okay, I think maybe, it's somewhere there. Okay. So there are few ones which I actually focused on was data profiler, Rubicon, and Data Compy, Hygia, and Cloud Custodian. These are all very popular open source, came out of Capital, and they play in various domains, particularly data and also cloud controls, because now we are 100% on cloud. So there are a lot of tooling we have to do, and those things are also open source. And a dashboard for your cloud operation, everything is available as open source. And we have been operating, right, for many decades in a highly regulated industry, and that actually has provided us rich insights, right, how to really operate within the strict boundaries, right? Those insights is what actually we have contributed to the toolings, all those things is what we have contributed as an open source project. And we give back to community in various forms. We run programs like Coders. Those programs primarily provide opportunities for middle school students as well as non-tech folks to get into tech stream and provide them toolings so that they can have enriching tech careers. One of the other way we really give back to community is actually sponsorship, right? So we want to have the thriving communities. Via the sponsorship, we ensure that the foundations are really inclusive and sustaining, right? So we are the sponsor for majority of the well-known foundations, FinOS, Python, Continuous Delivery, Cloud Native Computing Foundation, and our own Apache Software Foundation as well. So I have listed down the details of the projects as well as our GitHub page. Interested folks, definitely check it out. Yeah, this one really does, this is another thing, right? To keep it or not, after going through the things, I still kept it because I wanted to list down. One thing is pulse check. I am not really doing pulse check because after going through this, I don't think it really makes sense to go through what Cassandra really means to these folks. But I just kept it because I wanted to highlight the salient features. Right? These are all the things actually helped us, or these are all the things which is mainly the selling point for us to get into Cassandra. You will see why and what are those things in the upcoming slide. Let's breeze through this. Okay, the first reason our hallway conversation is why we are here. First reason I have already tried answering, probably because we are also heavily leveraging open source as well as we contribute to open source. The second one is Cassandra, right? The reason is Capital leverages Cassandra as its backend for various mission critical workloads. To start off, payments. Whenever customer makes payments to their credit card, that application and its backend is powered using Cassandra, and we are very well known for our credit card products and also rewards. That rewards platform uses Cassandra as its backend. And this cluster is one of the largest clusters in the enterprise. It has gone beyond the petabytes, and this cluster is mission critical for us because this is where predominantly what you see as our product, or this is what actually is the view customer sees us. And that is powered using Cassandra. There are other areas also we use, our customer data platform, as well as there are some serverless variations of Cassandra. In short, we leverage Cassandra as backend for various critical workloads, and that is the second reason why we are here. Okay, with all the things, whatever we need to take care, that's all taken care. Now Larry gets into the whatever the meat of the presentation. So first thing we are going to see is a pattern called staging. The second one we will see history and life. For that, we need to just set a stage. Imagine there is a customer-facing online transaction store, which we will name it as customer transactions, rightly named. You probably can relate to this if you are our customer or any credit card product, right? Where you are redeeming your rewards or where you are earning your rewards, all those things is what is represented in some form with a lot of brevity. It looks like this, right? And also it's for various regulatory reasons, it is actually append-only table and we cannot go and make any modifications. And this table contains all those information. You can connect this to my previous slide, the loyalty rewards. So this is the starting point of the staging. So what I really mean by staging pattern is there is a customer facing table, and what staging pattern does is it takes the same exact table and creates a different table, which we will name it as staging for this conversation. The key difference is they both are ditto same, but it uses a different partition key. We'll call it as process key for this. Right? There are various processes which writes to this staging table. The reason we will get into that why. So this is the premise in which we are going to see. This is the first step in the staging, which is there is a mimic of customer facing append-only table, and that is what we are calling it as staging. And the second step in the staging is there is a process which is going to look at all those changes which has happened, or in terms we call it as whatever got staged. Its primary job is to keep moving that from stage into the customer facing. Why? We'll really get into a data driven approach, and this is again an illustrative example similar to the table what we have used. Let's assume there is a customer named Apache who is going and buying a coffee, and their transactions after computation gets staged, looks like this. And due to the amount they have spent, they assume that they are having a bonus, and there is a different process which writes this into the same staging table. After the second record, it looks like this. So far good, right? This is where the reality strikes back. What we are, the main reason, maybe probably I missed out there, the main reason of having this separation of concern, right? We can have actually a validation and a verification taken care before it really hits customer base. So with that, what we found, for an example, that first transaction, what we wrote in the previous example, is having an incorrect amount. This always happens in distributed processing, right? On the other scenario, there was a transaction which the same customer made in a coffee shop too, did not even make it to the staging itself. These two scenarios happens day in, day out in a lot of the processing, particularly in big data. This happens where we computing something wrong, where we have to replay them, or there are some transactions we are trying to commit and it's not happening. These two cases, imagine if you are being the customer on the other side, where you are expecting, let's say, rewards of dollar amount 200, but you are seeing 100, and you are expecting something to show for your spend for rewards of 100, and it's not at all showing up. What kind of customer experience is that, right? That's primarily the reason why we are not writing directly anything into the customer facing, and also the regulatory reason directly not writing to the customer facing table. Have a table which stages everything through various processes, and then go through all your validation and verification taken care, and assume that in this example we have replayed the first transaction with the correct dollar amount, and the transaction which got missed out is also taken care by retrying, and that state looks like this. So for first transaction, made it with the right amount, and the transaction we missed out is also taken care, and that state looks like this, right? So now we have a process which takes all of this and then moves them to customer facing. This is exactly how our customer, when they log into portal, sees their whole transaction history. This is how it looks like actually in real world scenario. Connected to their account number and what are the things which has happened. But behind the scene, how it happens is actually through a pattern called staging. The reason I kept this is if you take care of your customer, they are happy and we are happy. Okay. So now we got the setting, right? Where and all this can be really helpful. I touched upon that point. Let's just drive home the fact, right? Using your partition key as a tool and carefully choreographing them will give you options to restart whatever you missed out, and you can go and restart, no change to the state of what customer sees, and you can even replay some of the things wherever you have seen there are misattributed done, and you can replay them. Still, there is no impact to customer. And also, a main benefit of this is there is a clear separation of concern we can establish, because whatever the processes we are really staging, they take care of only that part, because their primary task is to compute rewards, and there is a process which doesn't have any logic behind it. It just keeps moving the records, and that's what really customer sees. This whole setup is what we are calling it as staging pattern. Okay, now we have covered the staging pattern. Let's go to the second pattern, which is live history or current history. Okay. The core difference between, again, this could be something, a refresher, but the core difference between any classic RDBMS and Cassandra is the data is partition. You can call it as partition. Some databases call them as okay, I'm not getting it. MongoDB calls it as sharding, and there are different things. But main thing is there is a chunk of information kept in different nodes, and that is how the information should be retrieved. And that plays into the second point, which is the core difference, where you don't go and write your application and then go and design your schema. How you are going to retrieve your information is going to really dictate how your application is going to behave, is the core difference. And you cannot go and just ask for, give me all the records out of the database. That is classically how we do in RDBMS, which is a clear anti-pattern in Cassandra. With all the setup, let's take another example, which is similar to what the customer sees in the previous example. I have just again took out some of the things and then kept it just to establish the pattern. Let's name that as customer spend transaction, and it contains account number, customer name, same, blah, blah, blah. Okay. What really this pattern ensures is there is a process which keeps on writing to your customer facing, and also we are staging them, right? And if you really need the data which is aggregated, and there is a need for us to keep serving for real-time traffic, we can leverage this pattern. In this example, let's stretch the same, where customer sees all their earned information. Most of the things, in our case, on any other credit card, you probably would have seen how much of total rewards you have, right? How can we surface those things? Because that's somewhat for aggregated information, right? For that same example, we are defining a table which is called live, which has some of the information we are going to keep aggregating, where the clear need is we need to service them immediately. For those use cases, you can pick your partition key, which closely aligns to whatever your scenario where you need to pull them immediately. In this example, we are going to keep that as account number, because we want that specific accounts, what is their actual earn, which has happened. Same example, for the same aggregated information, there are clearly needs in which we need their information spanning over a period of time. For those scenarios, the same process, we can write it to live as well as history. And that's what we're calling it as customer spend transaction history, which if you notice, it exactly has the same information, but their keys are slightly modified. The reason is, in the previous case, we need the information immediately. But in this history case, right, these two are actually going to be handled by the same process, but they are two different tables. This history, we need some information where we define their top and bottom boundary in this case, let's take a date, right? So we need the information of a particular account spanning over a period of time. For those scenarios, we pick our partition key, which we are keeping it as same, account number, but there is also a date component included in it. So that way, we can try to fetch all the information what we need over a period of time. This is what we are calling it as history. Okay, similar to the previous example, let's go through the same with the data. So the same customer buying coffee again spent $20. The first spend transaction looks like this. The process, it reads all of this information and then that process will keep writing to live. If you notice, it picked what is the customer spent, and then at that point in time, their total spend looks like 20, and then that's what they have spent on that day too. But the history, if you see, it is related to the when it has happened, the same information, $20 total spend and $20 daily spend. With this, you probably may not be able to appreciate what this pattern helps. Let's take another transaction happening to the same, right? Same customer has gone and bought donuts. Who doesn't like coffee and donuts? So the same customer has got donuts. They have spent $10. So the second record, we got into customer spend transaction. If you noticed, the process which took this information and then wrote it to live, if you see, that day's spend reflects $10, but their total spend reflects $30. At the same point in time, how the history looks. Because there is another day, another transaction happened. On that day, their daily spend is 10, but their cumulative spend is 30. By having these two tables, we could actually serve both real-time traffic as well as batch traffic. Where this is really helpful, wherever you need a pre-aggregated data, instead of we doing all the computation on the fly, if you need this information to be computed ahead of time and kept it ready for you to serve for your APIs as well as processes where you need batch data. In the real example, where we are leveraging this is when, as I was previously explaining, when customer logs to our portal and sees how much of total rewards they have, right? That clearly comes out of our live table, and that is immediate, right? Because there are multiple things which fires off when customer logs in, and one of that is what actually fetching it out of this same table. The second use case where I am referring that as a batch use case is actually statements. Because if you notice, we are actually keeping that track of what has happened over a period of time. So for any given account, for a period of any time frame, right? It could be for that specific account for their cycle time. So we go and fetch the top and bottom, and then that's what goes into their statement. How much of rewards they have actually had in that specific period of time. So this is actually the real example where we have leveraged this pattern, and that could be also beneficial for anyone who needs pre-aggregated data for their use cases. All right, I think with this I covered pretty much what I wanted to cover. I'm Gokul Prabagaren, which I didn't cover, I just wanted to go through the end. One thing I want to say is, previously I spoke in Apache Con. The energy and the inspiration I could draw being in person is totally different. So there are a lot of inspiration I'm taking home. I definitely want to join the ASF. My mindset has completely changed. Okay, so I provided my LinkedIn QR code. Thank you, Paula, and the ASF for giving me this opportunity. If you liked what you heard, some details about Capital and Tech, I didn't cover. There are a lot of blogs which I have published to Cassandra Track, and also I have provided our career speech if you are interested. Capital, what's in your wallet? Okay, I have a slide for you. Anyone has anything?
I'm just curious, so I think transactions can be thought of as mutable inherently because you can authorize for one amount but then post for another amount, say in a restaurant. So how do you model this in stage in a customer facing?
So, okay, can't get into too much details of how it happens.
Okay.
I can definitely explain you off camera. But so what our process sees is not actually the address. So we receive only the post. So there is a process which takes care of that part. So we see only the posted information, but still we have to do this staging pattern because what we write to customer facing, once it goes there, customer sees it and then we are liable.
I have a question about this staging pattern, the first one which you presented. In that case, you have to, for example, from time to time reading that first table to prepare this aggregate to generate the output for customer facing. And my first question is how you read that table, for example, by token rings to read all these tables. And my second question, how you prune that table from data after reading that and moving to the next table.
You are right on money. Yeah. So that table, we have a TTL on that table. So we continuously keep pushing the data. That again goes into tombstone, that kind of problems with that table. But high level, that table, the information what gets into there, we don't keep it very long. But what goes to the customer facing, it stays forever. But the staging one, we keep removing them. There is a TTL on that table.
Okay, so you're using time window compaction strategy and just cutting the tail of the
we don't need to actually have the table beyond a day actually. So there is a TTL, so we even don't go and see what's there beyond a week. Right? So we only need that information for that particular day. Once, that's why there is a process which looks at that stage information, and once it is moved, so there are different mechanisms in which we track both this, right there. There is a pattern on that. So we keep some information in this stage so that we know which one has actually made it, which one hasn't. Accordingly, that process reacts. What I have shown here as a gear, that process. I don't know whether I completely answered.
Somehow I can imagine that.
Yeah, it has a TTL, and that table is what actually getting read for the second process too.
Okay, thanks.
Okay, maybe it's already time.